This is a video answer key for the review for test 3 in Math 1111. Question 1 reads, if the graph of g of x equals 4f of x minus 5 is the graph of f of x, what are the transformations? And so as I'm looking at the g of x, which is the transformed function, I first of all notice that I have a number being multiplied times the function itself. This from the generic formula is the a, which leads to either a vertical stretch or compression. The way we tell the difference is if a is greater than 0, such as 1, 2, 3, 4, 5, then we have a stretch. If that value is between 0 and 1, then we have a compression. So noting that it is a 4, I'm going to have a vertical stretch, which eliminates the last two options in this multiple choice format. I also then notice that I have a value being subtracted within the parentheses or from the x. This would be your h, and it is a horizontal translation. So you're either going to go left or right. And you have to remember that it's the opposite of what you probably would think. What I like to do to avoid making an error in the sign is to take the expression in the parentheses, x minus 5, set it equal to 0, and solve for x. And I see that x is positive 5, which means I need to move to the right because it is positive. So my answer is going to be vertically stretched by 4 and shifted right 5 units. Question number 2 says, which is the graph of x minus 2 quantity squared plus 5? Okay, so first of all, I notice that this is a square. The fact that it's a square tells me that I'm dealing with a quadratic function, and the graph of every quadratic function is a parabola, which is a U shape. In this format, which is the vertex form, I should be able to identify my vertex by looking at the H and the K. Okay, because my vertex in this format is HK. But again, remember, students get tripped up with that H. So if I take the expression x minus 2, set it to 0, solve for x, I see that the h, or the x coordinate, has a value of 2, and then I have k, which is plus 5, so I'm going up 5. So the vertex of my U-shaped curve should be at positive 2, 5 on the coordinate grid. So if I start looking at these graphs, here's 2. It actually appears that this first graph, and it should open up because the A is a positive 1. So it appears that this first graph is the one that I'm looking for. Now I really should check the others, but if I start looking, the second graph has a vertex at 2, negative 5, which is not correct. The third one is at negative 2, negative 5, again not correct. And the last one is at negative 2, positive 5. So it has moved left instead of right. So again, the first option, but the easiest way to recognize it is to locate the vertex. Question 3 is a similar question. Again, it asks you to identify the graph of this function. Again, I see that it is squared, which means, again, we have a quadratic function. And as I just stated, every quadratic function is a parabola, which is that U shape. Again, in the format that it's presented in that vertex form, I should be able to identify H and K, which will identify the vertex. Again, to avoid the sign error that a lot of students make, I would take X plus 2, set it to 0, and solve for X, which I get negative 2. So my vertex is negative 2, and then it's plus 5 or positive 5. So again, I'm looking for a U-shaped curve where the vertex, which is where the graph bottoms out or tops out, okay, it's either your minimum or your maximum. And so if I start looking at these graphs, let's see. This one is at 2, 5. That's not it. This one is at 2, negative 5. Nope. I'm looking for negative 2, positive 5. Okay, so this one is negative 2, negative 5. Nope. And then finally we get to the last one and we have negative 2, positive 5. That's the appropriate graph. Question 4 says, given the table below, determine whether the function is 1-to-1. Well, it has identified that it's a function, but let's double check. Remember, to be a function, you cannot have any repeat in the x values. And I do not have any repeat in the x values. To be 1-to-1, there can be no repeat in the in the y values. Okay, so to be a function, it's no repeat of x values. To be 1-to-1, it's no repeat of y values. And so this particular table does meet that condition. Therefore, this table is 1-to-1. So we would say yes, the function is 1-to-1. Question 5 basically asks the same question. However, instead of table form, it gives it to you in ordered pairs, in a set of ordered pairs. So again, if we think about whether or not it's a function at all, I notice that I have a repeat of the x value 7. So this particular display is not a function at all. And so if it's not a function, it is not, it's really a relation 1-to-1. It's not a function, so we would not even consider whether it is 1-to-1. So you have to be careful about that. They're trying to trip you up. Question 6, you're given 4 graphs and you're asked to determine which of the graphs is 1-to-1, and you can select more than one answer. Remember, to be 1-to-1 from a graphical perspective, it has to pass the horizontal line test. If I can draw a horizontal line and my purple function only crosses, my horizontal line only crosses once, then the function is 1-to-1. So the graph on the top left is 1-to-1. You may think that at this point this particular function is not, but this little curve, it is curved, so there's always a little bit of a tilt. So this one also is 1 to 1. Okay, the third option on the bottom left is not, because if I draw a line there, I'm crossing 1, 2, 3 times. 3 is more than 1. This is not a 1 to 1 function. Also, with the last one on the bottom right, I cross 2 times. 2 is more than 1, so it is not. Okay, the horizontal line can only cross the graph 1 time at any given point. All right, question 7 says for the functions f of x equals 2x minus 3 and g of x equals 5x plus 5, find f composed with g at x. This is a composition. This little open circle dot here represents a composition. So we say composed, and remember that's a sequence. In this case, we start out, we plug x, and I'm going to use different colors here to try to help you see the difference. Okay, we're going to plug x into function g. See, x goes into g. Okay, so when I plug x into g, I get 5x plus 5. I then take function g and plug it into f wherever there is an x. So I would have 2 times the 5x plus 5. G is 5x plus 5, and it's going to take the place of x. And then I still have the minus 3 part of function f. And then I'm going to do the math. Okay, so I'm going to simplify. I'm going to distribute. 2 times 5x is 10x. 2 times positive 5 is positive 10 minus 3. Simplifying, 10x plus 7. 10 minus 3 is positive 7. So this is f composed with g at x. Remember, with a composition, it's a sequencing. You start at the x and basically work your way backwards. Question 8 says, given the following functions, find and simplify f divided by g at 1/2. So in this case, we have to plug 1/2 into function f, and we have to plug 1/2 into function g and do the math, and then divide the two results. Okay, so I'm going to put my division bar, and I'm going to substitute 1/2 into function f. So I have 8 times 1/2 squared plus 4 times 1/2 minus 1. And I'll come back and do the math in a minute. I'm then going to also substitute 1/2 into function g, and it goes in the denominator. And then we go back and we do the math. Okay, I'm going to do the math in the denominator first. It doesn't matter which one I do first. Okay, so 1/2 times 6. Half of 6 is 3 plus 3, and 3 plus 3 is 6. So ultimately, the value in the denominator is going to be 6. Okay, now I'm going back to do the numerator. 8 1/2 squared. 1/2 times 1/2 is 1/4, plus half of 4 is 2 minus 1. 1/4, if I divide 8 by 4, I get 2. So I have 2 plus 2 minus 1 in, the numerator. And I'm going to go back and finish that math. 2 plus 2 is 4, minus 1 is 3. We already determined that the denominator was 6. When I simplify that, 3/6 is equal to 1/2. So it just so happens when I substitute 1/2, the value for f divided by g happens to be 1/2. Now guys, it doesn't always work that way. It just happens to be in this particular example or this particular problem. For question 9, you're given two functions and they want you to find f minus g at 1/2. So you have the minus sign. So this is subtraction. So again, it's the same idea. We're going to substitute 1/2 into f. We're going to substitute 1/2 into g and subtract the two results. So again, I'm going to kind of color code it for you. If I plug 1/2 into function f, I have 8 times 1/2 squared plus 4 times 1/2 minus 1. If I substitute 1/2 into g, I have 6 times 1/2 plus 3. So I'm going to do the math. So 8 times 1/2 squared, that's 1/4, plus 4 times 1/2, half of 4 is 2, minus 1, minus, and then I'm going to do the other calculation, half of 6 is 3 plus 3. Going back to do the math again, keep working through it. 8 times 1/4 is 2 plus 2 minus 1. And then we're going to subtract 3 plus 3 is 6. So 2 plus 2 is 4, minus 1 is 3. 3 minus positive 6 equals negative 3. So f minus g at 1/2 is negative 3. Guys, I'm doing a lot of that math in my head, okay? If you cannot do the fractions or do the calculations in your head, please use a calculator. Okay, question 10 says, find the inverse of the following 1-to-1 function, and you're given f of x equals negative 3 times the square root of x plus 2 minus 6 for x greater than or equal to negative 2. Okay, so they tell you this is a 1-to-1 function, and remember that f of x and y are the same thing. The first step to find the inverse is to interchange the x and y. Okay, so I'm going to interchange the x and y, which gives me x equals negative 3 times the square root of y plus 2 minus 6. And then I need to solve that equation for y. So I'm going to add 6 to either side. So I have x plus 6 equals negative 3 times the square root of y plus 2. Then I'm going to divide both sides by -3 so that I have x plus 6 divided by -3, and that equals the square root of y plus 2. I need to get rid of the square. We get rid of the square by squaring, and we have to square both sides. So I have x plus 6 squared over -3 squared is +9 equals y plus 2. And I'm almost home free because remember my goal is to get the y by itself. So I need to subtract 2 from either side. So I have x plus 6 squared over 9 minus 2 equals y. But remember that y that we just found is f inverse. So this is f inverse of x. You're just doing algebraic manipulation, solving an equation for a variable. Number 11 is the same type question. It tells you you have a one-to-one function. Notice this is a parabola, okay, and it says for x greater than 0, which means you're only going to look at basically half of the parabola from 0 towards positive infinity, so that basically you're ignoring this other half. Again, that's what makes it one-to-one, but they tell you that so you don't have to go through and verify that, but I just wanted to point that out. Remember that f of x is the same thing as y. First step, we interchange x and y. So I have x equals 5y squared plus 6. Again, once I interchange x and y, I need to solve for y. So I'm going to subtract 6 from either side. So I have x minus 6 equals 5y squared. I'm then going to divide by 5 so that I have x minus 6 divided by 5 equals y squared. I then need to undo the square. We undo the square by taking the square root. I'm sorry, I put the plus or minus on the wrong side. So I have y equals the square root of x minus 6 all over 5. It is positive again because we were looking at from 0 to positive infinity, which means that my y value is positive. So it is positive in terms of which one, whether you should choose positive or negative. Again, remember that that y that we just solved for is now my f inverse. Question 3 is another question about finding the inverse. Obviously, that's an important concept. So here again, it tells us that it's one-to-one, but hopefully you can recognize this is a line, and any line is one-to-one except for a horizontal line. So again, the f of x is a y. We're going to interchange x and y. So I have x equals 5y plus 3. And then I'm going to solve for y. So I'm going to subtract 3 from either side. We have x minus 3 equals 5y. I'm then going to divide both sides by 5. I'm trying to get the y by itself. So I have x minus 3 over 5 equals y. Again, once you have it solved for y, remember that that is now your F inverse. Question 13, it says determine the vertex of the parabola whose graph is given. Okay, the parabola, okay, is the U-shaped curve. The vertex is where it changes direction. It is your maximum or your minimum. So it would be this point here. Okay, this is my vertex. And if I look at my graph, and remember, we're going to write it in terms of an ordered pair, and we always write an ordered pair in the form x comma y. So my x value is -5. My y value is +5. So my vertex is at -5, 5. Guys, don't overthink it. It's that simple. You're trying to locate the point where the graph changes direction or your maximum or minimum. Question 14 asks you to determine the axis of symmetry for the parabola. The axis of symmetry is kind of that imaginary line that you would fold the graph across so that you couldn't tell the left side from the right side, and it always goes through the vertex and is a vertical line. Okay, so the axis of symmetry, the formula is x equals h. H is the x coordinate of the vertex. For this problem, the x coordinate of the vertex is -5. So my axis of symmetry is x equals -5. 15 says determine the x-intercepts of the parabola whose graph is given below. Okay, remember the x-intercepts is where the graph crosses the x-axis. The x-axis is the horizontal number line. So I cross at this point and at this point, and typically we do write those as ordered pairs. So this would be 2, 0, and -5, 0. Again, guys, don't overthink it. Okay, don't overthink it. You're just looking for where it crosses the x-axis. The next question says to determine the the y-intercept. The y-intercept is where it crosses the y-axis, which is the vertical number line. So it looks like it crosses at this point. And again, as an ordered pair, that would be 0, -2. Remember that ordered pairs are always written in the order x, comma, y. Number 17, we need, let's see, it says, given the polynomial has a degree of 3, which of the following most accurately describes the number of turning points of the polynomial? Okay, so this is kind of a formula. It's a thought-provoking question, but if you'll remember, we talked about how that a polynomial has at most n minus 1 turning points. Okay, so if that's kind of my formula, if you want to think about it as a formula, then I can see that I can eliminate three choices, because 3 of my choices say at least, and the phrase should be at most. The n corresponds to my degree. So in this case, my degree is 5. 5 minus 1 is 4. So I would have at most 4 turning points. That's just kind of a formula. Okay, so you have to kind of remember that formula. You might want to make sure you have that in your notes. It says, question 18 is another one of those thought-provoking questions as well. It says, given that the polynomial has 4 x-intercepts, which of the following most accurately describes the degree of the polynomial? This one's a little bit trickier. It tells you that it crosses the x-axis 4 times. And typically what we know is that the number of x-intercepts equals the degree. Okay, at most. So it would not be bigger than 4, so it couldn't be the ones with 5. Okay, because our x-intercepts are our zeros. Our zeros correspond to the degree. So our degree is going to be at most, the biggest it could be is 4. Okay, is at most 4. I'm having a moment of pause, guys. I'm thinking about that. It has to be 4 for sure, but we could have imaginary. So I think instead of at most, I would go with at least. I'm sorry about that. I just had a moment of pause, but I would go with at least 4 because it's going to equal 4 for sure, but I could have imaginary solutions so that the degree is higher. So it has to be at least 4. Not at most. Okay, so I would use the phrase here if you want to kind of write it down. At least n would kind of be the phrase you want to look for. At least n, or at least the number of intercepts. Question 19 says to find all the real and imaginary zeros of the following polynomial, either by factoring and or the quadratic formula. Okay, so you can do either, whichever you choose. This particular problem, I notice, can be factored. So we're going to set this equal to 0. 0 equals x to the 5th plus 3x cubed minus 10x. And the first thing that I notice is that I have an x in common. So I'm going to have x to the 4th plus 3x squared minus 10x. And then I'm going to try to factor my x to the 4th. X to the 4th would be x squared times x squared. I need a pair of numbers that multiply to 10 and subtract to 3. That would be 5 and 2. 5 times 2 is 10. 5 minus 2 is 3. The 5 is positive and the 3 is negative. And that is equal to 0. So I know that one of those pieces, one of those factors, had to be equal to 0. So either x equals 0, x squared plus 5 equals 0, or x squared minus 2 equals 0. And then I have to solve each of those respectively for x. Well, x equals 0 is already solved, so I have 0, 0 as a solution. For the second one, I'm going to subtract 5 from either side. So I have x squared equals negative 5. I then have to square root both sides. It could be positive or negative. So x is positive or negative I on the square root of 5. I get an I because the 5 under the radical is negative, so it comes out and is the imaginary unit, and the 5 stays underneath because it is not a perfect square. X squared minus 2, I'm going to add 2 to either side. So x squared equals 2. Again, I'm going to undo the square by square rooting both sides, and it could be positive or negative. So I have x equals positive or negative square root of 2. So I do have, and I should have when I'm done, I should have 5 solutions, and I do because I have 0, 0. I have I square root 5, comma 0. I negative I square root 5, comma 0. Square root 2, comma 0, and negative square root 2, comma 0, if I write them all as ordered pairs. All right, then you have the last question on the review, which is question 20, and it says, the polynomial f of x given below has x equals -1 as a 0. Find all the remaining zeros of the polynomial. So we know that one of our answers is -1. And the intent of this question is for you to use the rational root test to try to find the others. So I'm going to divide out the -1, and I'm going to do that using synthetic division. Okay, so I've got my problem set up. So I have drop the 1, -1 times 1 is -1, -5 plus -1 is -6, -1 times -6 is 6, 4 plus 6 is 10, -1 times 10 is -10, which is 0. And I should get a 0 because they told me it was a solution. So I had an x cubed. I have divided out that solution. So this is now 1x squared minus 6x plus 10. And I don't believe that'll factor, but since it's a quadratic, I can then apply, whoops, sorry, I got the sign wrong there. I can then apply the quadratic formula to solve this quadratic equation to find the other zeros. So to use quadratic formula, remember that you have your a, which is the number in front of the squared term, which is a 1. B is the number in front of the x, and c is the constant. So I have x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so I've plugged and chugged into the formula, and now I'm going to do the math. Okay, so the opposite of -6 is 6, plus or minus the square root. -6 squared is 36, minus 4 times 1 is -4, times 10 is -40, all over 2. So I have 6 plus or minus the square root of -4 over 2. So that's 6 plus or minus 2i. 4 is a perfect square. Square root of 4 is 2, and it's an I because it's negative over 2. I then have a common factor of 2 that can be divided out. I'm going to pull the 2 out. So I have 3 plus or minus I all over 2. The 2 in the numerator will divide out with the 2 in the denominator. So ultimately, my answer is 3 plus or minus I. So there are my other two solutions. We know -1 is the solution, and I should have a total of 3. So I have 3 plus I and 3 minus I. And that concludes the video answer key for the review for test number 3.